Hi everyone, welcome back to Activity 21. Today we talk about verifying our trig expressions. Now with our trig expressions, our goal when we verify, essentially it is the same process that we have done, however they are giving us the answer essentially. We are trying to make one side turn into the other sides. The steps are the answer. You're basically showing your work to answer the questions. Again, when we verify, the only thing we are manipulating is one side of the equation. Because again, they are essentially telling us what the goal answer is. We're showing them how to prove it. So it's not solving an equation so much as it is simplifying to prove that one side equals the other. So it's the exact same process that we've been doing. We've done the hard part. We've seen those examples. All right, today we are going to talk about then just verifying to prove something's true. Now, usually when we verify, like we do right now with step one, is we usually want to manipulate the harder side, the one that looks a little bit more complicated, and into the other side to make it the goal. Now, sometimes you can officially manipulate both sides to be the other, but usually it's easier to work with the more complicated side. So we are going to make, in this first example, sine cubed x our goal answer, right? So all going to do, we're not going to manipulate anything. We're only going to manipulate the stuff on the left-hand side. So in the left-hand side's case, notice to start, we actually have a GCF we can pull out of sine of x. And when we divide that out, we're left inside the parentheses with 1 minus cosine squared x. And again, we do nothing with the right-hand side. It's only that left-hand side. The right-hand side's the answer. Well, we know from our Pythagorean identities that 1 minus cosine squared can be rewritten as sine squared. And then sine of x times sine squared of x is going to give us that answer that we were going for of sine cubed of x. So we know that we are done because the left side now matches the right. In the next example, again, we notice we have another Pythagorean identity. And this time our Pythagorean identity is that we can rewrite tangent squared plus 1 as secant squared. And again, we want our goal this time to be that left-hand side because that's the less complicated side. So that's what we're going to probably try and simplify to be. So we have tangent squared x over secant squared x. And we know that we can officially rewrite this so that instead of being secant squared on the denominator, 1 over secant squared can be written as cosine squared in the numerator. And then from there, tangent can be rewritten as sine squared over cosine squared. And then what we'll notice is that our cosine squared in the denominator can cancel with our cosine squared in the numerator. And our final answer is sine squared x, which again was our goal. In the next example, we want our goal here to be 1, right? That's the less complicated side, so we're going to want to make sure we try to get this to simplify to be 1 using the left-hand side. Now, don't be tricked by the sine squared minus cosine squared. This is a minus sign, so this is not equal to sine squared plus cosine squared because it's a minus sign, not an equal sign. Okay, so we're going to ignore that for a second. And we're going to focus on the numerator to start. And what we noticed with sine to the fourth minus cosine to the fourth is this is actually a difference of 2 squares, right? And we know the difference of 2 squares. We have something squared minus something squared equals a plus b, a minus b, right? So in this case, sine squared is sine to the fourth. Cosine squared is sine to the fourth. So we would have sine squared plus cosine squared, sine squared minus cosine squared. And the denominator here, then we are going to leave untouched for a moment because what we're going to notice then is now that we took that difference of 2 squares from the numerator, okay, we can't just cancel things out, but again, we look for the difference of 2 squares, and what we notice now is this expression and this expression can cancel out so that we're just left with sine squared plus cosine squared, which if they're adding sine squared plus cosine squared, we know that equals 1. So we simplified it to our final answer. All right, last one. We want to make our goal this time this cosine squared. Okay, so we're going to manipulate the right-hand side. Now, we are not allowed to cancel things out here right away, even if we could, because we have this plus sign. Okay, so again, that makes things a little bit trickier because we have that plus sign. So what we're going to do instead is let's focus on simplifying the top versus the bottom. Okay, so for instance, I'm going to just simplify the top. If I have cosecant times cosine, I know cosecant is 1 over sine, and then that times that cosine. Okay, so that's my numerator. My denominator, on the other hand, I can simplify here. Sine is, or excuse me, tan is sine over cos. Cotan is cos over sine. And if we want these two to be able to be added together, we would need a common denominator. In this case, our common denominator could be cosine times sine. Now this left-hand side, in order to get a sine on the bottom to become cosine times sine, top and bottom need to be multiplied by sine. So we now have sine squared x over there. And then on this side, we already have a sine, but we want to multiply top and bottom by a cosine of x. So that cosine times cosine becomes cosine squared. We have that all over our common denominator. Well, we know that sine squared plus cosine squared equals 1. So right now we have two things happening, okay? We have a numerator of our fraction, which was 1 over sine times cosine, aka cosine of x over sine of x. And then in the denominator, we have a whole separate thing. We have 1 over cosine of x times sine of x, right? After we kind of individually looked at each piece. Well, we know to get rid of this fraction within a fraction, what we can do is we can multiply by the reciprocal. So instead of being 1 over cosine times sine, it's now going to be cosine times sine over 1. And now we are able to get rid of that denominator piece because we multiplied by that reciprocal. Last step then is we can cancel the sign in the denominator with the sign in the numerator, and we end up with cosine times cosine, which is cosine squared, as our final answer, and we know that from over here, that's what this is supposed to be. All right, thanks everyone for watching. We'll work more with verifying in class.